Last time we looked at some examples where we looked at how we can find the solution to a system of inequalities. And then we worked a little bit more with it. We found perimeter, we found area, and then we even rotated to find volume. And so we're going to do a little bit more with this idea of revolving things around in the XY coordinate plane and work with that and see if we can kind of visualize more while still reviewing some concepts. So we're going to start with this example here. It says, sketch the region bounded by the lines y equals 3, y equals 1, x equals 1, and x equals 6. Okay, so I'm going to do this all in different colors so we can see this more clearly here. Y equals 3, that's going to be a horizontal line going through 3 on the y-axis. Y equals 1 is a horizontal line going through 1 on the y-axis. X equals 1 is a vertical line going through 1 on the x-axis. And then x equals 6 is a vertical line going through 6 on the x-axis. Okay, so the region that's bounded by these lines is this rectangle right here. Okay, part B. Determine the perimeter of the region. So the perimeter, we just really have to look at how many units it is in terms of its length and its width. And so counting this out, it looks like this has a height of 2 and the length is 5. So the perimeter is just the measure around the rectangle. So 5 plus 5 plus 2 plus 2, which is equal to 14. So this is 14 units. Now determine the area of the region. So still use those measurements, the 5 and the 2, because the area of the rectangle is going to be the base times the height. So that's going to be 5 times 2, which is equal to 10 units squared. Okay, now comes the part where we revolve things around. So draw a picture of the region being revolved about the x-axis. So what I like to do to help us imagine what this looks like is first imagine what it looks like if we were to reflect it across the x-axis. So if you take this rectangle and reflect it across the x-axis, you end up here. Now, how do you actually reflect it? Where does that rectangle move as you start moving it towards the other side of the x-axis? That's what we want to draw out. So since it's revolving around the x-axis, you can imagine it makes circular motion around the x-axis. Now, what I like to do is I like to take each corner of the rectangle and draw the movement that it makes around the x-axis. So say I take this corner here, and it moves around the x-axis like that to revolve around. Same with this corner over here. And then if we just draw that for every single corner, where does each corner end up? So now we start with the one that's all the way up top. And if that were to revolve all the way around the x-axis, that's what it would look like. And same over here on this side. So now we can hopefully maybe see what that three-dimensional figure looks like a little bit better. So again, what I did was I took the rectangle that we started with, I reflected it across the x-axis, and then I drew in the line for each vertex of that rectangle and the movement that it would make in order to revolve around the x-axis. So how do we describe this geometric solid that's formed? Well, what it really is it's a cylinder, right? A cylinder is an object that has a base that's a circle, and it has two of those, right? One on top and one on bottom. Otherwise, if it just had one base that's a circle, we would call it a cone. So, in this case, we have a cylinder, but there's a hole going through it, right? So you can describe it as it's a larger cylinder with a smaller cylinder removed from where? From the center of that cylinder. Okay, now determine the volume of the geometric solid. So, how do you find the volume of this? Well, we can find the volume of the larger cylinder, and then we can subtract out the volume of the smaller cylinder that's removed. So the volume of a cylinder is pi r squared times h, right? So the area of the base, pi r squared, times the height of the cylinder. So let's start with the larger one. So the radius of the larger cylinder is going to be 3. So pi times 3 squared times the height of the cylinder, which is 5. We're kind of looking at it sideways. Minus pi times the radius of the smaller cylinder, the hole that's taken out. So that's a radius of 1. So this will be pi times 1 squared, and it's still a height of 5. Okay, so 3 squared times 5, that's 45 pi, minus 1 squared times 5 times pi, that's 5 pi. And so 45 pi minus 5 pi is equal to 40 pi units cubed. And again, this is the way that we would give our answer as an exact answer. If you wanted an approximate answer, you could feel free to multiply 40 times pi and get an approximate answer.